Okay, so in this video we're going to run the classifiers within a Java program and not within the WEKA Explorer GUI. We'll run two classifiers, SMO regression and random forest. Three most important things that we'll be doing is building an instance object of our ARF data, obviously building a classifier object and loading those instances into the object, and then building the evaluation model to evaluate the data using a tenfold test. So back over to Eclipse, the IDE that I'm using. Let's copy the original build spy ARF program. You can see we're still using days ahead of 5. We'll keep it at that. Let's rename this, or let's do a save as. And we're going to build, this case, not a file, but we're going to build a string. And use classifier. That'll give us one small error. We just let Eclipse fix it for us to rename it correctly. And like I said, we're going to be using a string, so let's use a string writer. The string will store our ARF data. And we will pass that to our print writer just to make things a lot easier for us. And we're done. We're done with building the ARF file. So now we want to add in loading the classifier and things like that. Let's get rid of the close statement here. And first thing we need to do is to build the ARF file in the object called instances. The WEKA core instances, we'll call them instances. Keep it simple. Instantiate it. And we're going to use a file reader. Or we're going to use a string reader. Now if you want to keep it in a file, just use a file reader. In this case I will use a string reader, passing to it our string, and turn it into a string format correctly. Once that is done, we have to tell the instances which attribute is the one we're going to classify on, which is, it's always the last one, but when you're, and it's done for you automatically in the WEKA GUI. You can actually change it within the WEKA GUI, but here we have to set the index, class index. It's offset by 0, so it's the instances number of attributes minus 1. And I can see a string reader hasn't been defined, so let me just add that. And so the ARF file is now in an instance object. Let's create the classifier, the SMO regression. And load in build the classifiers with our instances. That generates that'll generate an exception. We'll just add it with a throws at the top in our main method call. So now that the classifier has built itself using the instances passed, we now need to do an evaluation to do our tenfold evaluation. Now we use the evaluation class. And we pass the instance data. And we're doing a cross-validation, a tenfold, so we call crossroad validate. We pass it our classifier, our instances, the number of folds we want to do, in this case 10, and we need to pass it a randomizer function. So we use the Java util random function. And the last argument is not used, and since it's a variable list, we can just drop it. So by this time the evaluation's been done. Let's take a look at our results. And first we'll take a look at the correlation coefficient. Using the evaluation object, we get it. And the other thing that we looked at, because we know the correlation coefficient is going to be 0.99, whatever. Let's take a look at the mean absolute error. I think we're done. Let's do a save, see if we have any errors here. No errors are showing up, so we can just run it. And if you remember, when we ran this in the GUI, this takes a while, so we're going to stop it and we'll restart it after when the evaluation has been done. But briefly though, these two warnings that you see here are from those the math jar files that we added in the previous video. You can ignore those since they're only warnings, and if you want to get rid of them, you'll have to use your own log4j filter. Okay, and so we're back, and as you can see, that took about 6 minutes to run. And here's our two answers. Again, there's the correlation coefficient at 0.99, which is really great, and the mean absolute error of 1.64. Pretty much what the WEKA GUI Explorer produced. Obviously, they're using the same methods and objects. Okay, now we're going to do pretty much the same thing for the Java program that used nominal values, so we'll just copy it, do a save as, and change the word file to string, calling classifier. This time we'll call the random forest classifier. Quick fix. We're not going to use a print file this time. We're going to, again, write it to a string writer. And get rid of the file and put in swtrain. That should be it. Everything else remains the same. We're going to be doing nominal values of buy and sell. Let's get rid of the close for good luck. First thing we want to do again is build the instances. And use a reader. Again, if you want to keep it in a file, use a file reader. But since ours, in this program, we're using a string, we'll need a string reader. Again, we've got to tell it which attribute is what we're going to classify on. Which is always the last one, but offset by 0. Next we call we built the random forest classifier. have it build the classifiers from the instances. Again, that does A throws an exception. We'll just add it to our throws clause at the method called main. And then evaluation. With our instances. Oops. And then the tenfold cross-validation. Pass it the classifier, which is called RF, the instances called instances, the number of folds, 10. The third argument is a random function called random. And the last attribute call for the method is not used because it's a variable list. And this quickly we'll just take a look at the weighted precision. Save it, no errors, let's run it. Again, it takes a while. Of course, a little faster than the SMO regressor classifier, but it still takes a while. Oh, and then we're done. There it is. Weighted precision of 0.702. And in the next video, we are going to take this class file, this Java file that we just built, and we're going to iterate over the number of intervals for both the short and the long-term moving averages, and see if we can get a better weighted precision.